In this recording, we're going to look at graphs of the other trig functions, the reciprocal functions, cosecant, secant, tangent, and cotangent. You're going to need a piece of graph paper to make these graphs. The good news is, for our course, you're not going to have to do these reciprocal function graphs very often. Really, it's a matter of recognizing them. But to introduce them, I'd like to go through where they come from. So let's start with something that we're familiar with, the graph of y equals sine of x over the domain negative 2 pi to 2 pi. So first thing I'd like to do is have you graph that function, sine of x, and we're going to use a slightly different scaling here because I want to go further in the vertical direction. So we're going to use a 2 to 12 ratio here. So make this graph using a 2 to 12 ratio, so up 2 boxes for 1, horizontally 12 boxes for 2 pi. And when you have this graph on your paper, I'd like you to play the recording. Okay, so the next thing we're going to look at is we're going to graph the cosecant function, which you know is the reciprocal of the sine graph. So what we're going to think about is what are some easy points on this sine graph to take the reciprocal of. So a couple points I'm thinking about right here are 1. Certainly that's easy to get the reciprocal of. So we know that's a point on the reciprocal graph, the cosecant graph. Another point that I'm looking at here is the point half. It occurs twice here. So I'm going to plot those points. 1's reciprocal is 1. Half's reciprocal is 2. Okay? Half's reciprocal is 2. Over here, negative 1's reciprocal is negative 1. Negative half's reciprocal is negative 2. That happens twice. Okay? So I'm starting to generate, just highlight what we're doing down here. We're graphing the cosecant of x function within the same domain. Let's add some more points. Okay? So out here as well, and over here as well, we take those same points, the 1's, the negative 1's, the halves, the negative halves, because they're easy to take the reciprocal of. So for the same x value, in other words right above it or below it, you're just going to take the reciprocal. Now, another thing that's easy to take the reciprocal of, it's just not easy to conceptualize, is the reciprocal of 0. So these are places right here when you think about what happens if you take 0, make it into a fraction like 0 over 1, and then flip that fraction, get 1 over 0. And you learned a long time ago that anything divided by 0 is undefined. So the way we represent that is with a vertical asymptote. Okay? You've seen asymptotes in your log functions and in your exponential functions. Okay? So I'd like you to take your ruler and just draw dotted lines here. Any place the sine graph has a 0, the cosecant graph has a vertical asymptote. I'd like you to make a note here. These are asymptotes where the cosecant of x is undefined and the sine of x is 0. When you're ready, keep playing the recording. Okay, now we're ready to connect these dots. The cosecant graph looks like a bunch of u's and upside down u's. Okay? Reason for that is as sine gets closer and closer to 0, we're dividing a much bigger number by a much smaller number in the cosecant graph. We're getting closer and closer to infinity. And so this approaches infinity, and as the x value gets closer to pi, and it gets closer to 0. So you have this U shape here. Basically use these 3 dots as your anchors and don't go any wider than the asymptotes. It does not touch the vertical asymptotes. And of course you can see that that's going to happen 3 other places in the graph as well. That's the graph of a cosecant. When you're ready, we'll look at how to make a secant graph using the graphing calculator. Since cosine is so related to sine, I think we have a general sense of what the secant graph might look like. So we're going to skip ahead and just use the graphing calculator. So if you have a graphing calculator, go ahead and take it out. If you don't, you can just play along with me. I'd like you to graph y equals cosine of x. Of course, you know what that graph looks like. There's our cosine graph. I want you to think about some of the key points that are going to be easy to take the reciprocal of, and therefore what the secant function will look like when we do so. So points like this, where cosine is 1, secant's just going to still be a 1. When cosine is 0, secant, the reciprocal of 0, remember, is undefined. So you're expecting to see vertical asymptotes right here, though we're not actually going to see them on the graphing calculator. And so if this is a 1 and it's approaching an asymptote, I should see a u centered right here on the y-axis. Let's see what happens. So we go into our y2, let's create a little mini fraction, and let's put in 1 divided by the cosine of x. Then let's look at that graph. This graph's going to come out red. Okay, it's doing what we thought it would. It has vertical asymptotes any place where the cosine function is 0. It has values of the reciprocals of the cosine anywhere where the cosine is not 0. So at 1 it's 1, at negative 1 it's negative 1, and where cosine approaches 0, decreasing, secant approaches infinity. I'd like you to make a sketch of this function on your graph paper. Okay? Just make a sketch of this function. Okay, so once you've made a sketch and labeled which one is the cosecant, which one is the cosine and which one is the secant, you're ready to move on to our last set of functions, which is tangent. I'd like to introduce the tangent function by looking at this gizmo. This is a great gizmo. First off, tangent, as you remembered, is the y over the x. So down here we can see that it's defined as the sine over the cosine, because on the unit circle, sine is y, cosine is x. So right here we can see what's going to happen to this reference triangle as we increase the angle. Initially, let me put this back to 0. Initially the height of the triangle is 0. The width of the triangle, or the base, is 1. So 0 divided by 1 is 0. But as I increase the angle, see what's happening over on the right side to the tangent ratio. Okay? Get it close to 2.5 right there. It's a 45 degree angle. Here we can see it in degrees. In radians it's 0.25 or pi over 4. And that's where the sine and cosine are equal. Remember that 45, 45, 90 triangle. So when we divide the sine by the cosine, we get a 1. That's going to be an easy point for us to plot. Okay, so we had a 0, we have a 1, and now we're going to see what happens when we increase the angle closer and closer to 90 degrees or pi over 2. Well, it just went off my screen because the sine divided by the cosine got bigger than 2. Okay? And as we do so, you can see in my triangle the y is getting much bigger in comparison to the x. And so it's approaching positive infinity. Okay? Let's go back to our graph paper and formally make. Okay, so once again you're going to set up your axes for the tangent of x over the domain -2 to 2, say -2 pi to 2 pi. Once you've set up your axes and you're ready to proceed, go ahead and play the recording. Let's start with some easy points like we saw in the gizmo that are easy to plot. First of all, where the tangent function is 0 is anywhere where the sine is 0. So at 0, pi, 2 pi, etc. Next, let's hit those spots that came out to be 1s or -1s. Okay, so when we have pi over 4, which would be right here between 0 and 0 and pi over 2. The sine of x is equal to the cosine of x. So 45 degrees, tangent's 1. And down here as well. I guess what I neglected to show you was what the full tangent graph was going to look like. I guess we'll see it in a moment. Next, I'm going to repeat that pattern because that pattern repeats throughout the interval. Okay? From negative 2 pi to 2 pi, there's lots of places where in fact, halfway between 0, pi and 3 pi over 2, there's another place where it's 1. Halfway between pi over 2 and pi, there's another place where it's negative 1. Next, I need the places where tangent is undefined. So I find those places where cosine, the denominator, is 0. That'd be something, for example, like pi over 2. Okay? Where cosine is 0 and sine is 1. And at those places, I draw vertical asymptotes. So you can kind of see how the shapes get taking place here. Looks like a straight line in here, but it's actually going to look like this. That's what a tangent curve looks like. Okay, and it repeats, has 4 full cycles between negative 2 pi and 2 pi. Again, it's a cyclical graph, just has a different period than sine or cosine. On the same axes, we're going to make a cotangent graph. Okay, the thing I'd like to start with is the easy points to plot. For example, the places where cotangent is undefined. So those are the places where tangent is 0. Okay, I'll try to make that clear. Cotangent is the reciprocal of tangent. So where tangent is 0, and you do the reciprocal of 0, you're going to get undefined. So that's why I'm going to have these magenta-looking asymptotes on the cotangent graph. Now the next thing to think about is some points on the cotangent graph. So those would be points where the tangent graph is undefined, like right here, right here. That's where the cotangent graph is going to have a 0. Let's plot all those points. So those are those blue dots there. Next, any place where tangent is a 1 or a negative 1, we've got easy points to plot on the cotangent graph, because the reciprocal of 1 is 1, and the reciprocal of negative 1 is negative 1. So for example, here's a point on the tangent graph that's a 1, so the reciprocal of 1 is 1. Here's a point on the tangent graph that's a negative 1, so the cotangent is the same. You flip over a negative 1, you still get negative 1. And finally the curve looks like this. So I'd like you to label the y equals cotangent graph and the y equals tangent graph, and you're done. Thanks for watching.